Oh, hey, how are you? Sorry about this. Just found out I got to make this video today, so let's get to it. Sorry about this. Wasn't ready for this. What what color do you like? Let me get me out of the way. Here we go. What do you like? What's your favorite color? Okay, pink. Okay, here we go. Pink it is. Thank you. All right. Here we go. Line of best fit. We talked a little bit about line of best fit and how we use math to make this world make more sense, the X and Y. And line of best fit is, you got a whole bunch of dots, and then you find the line, as we saw so well with Desmos yesterday. You find the line that works for them. I say you find the line. There's a way mathematically, just by pushing a button in Desmos, mathematically it comes up with the line of best fit, because it's able to do a mathematical correlation is what it's called. And we've talked a little bit about that correlation. Just as a hint for you level 4 students out there, if it's highly correlated, then the dots are really, really close to the line. If it's not very correlated, the dots are all over the place. Not a very good correlation. But we've been talking about positive correlation. That's this graph right here. It's got a positive correlation because when one goes up, the other goes up. When one variable does something, the other variable does something. When one variable goes down, the other variable goes down. Positive means it's got the same directional correlation. But you might have a negative correlation. And a negative correlation is where when one variable, say, goes up, as we go up the x-axis as it goes up, the other variable will do the opposite. It will go down. The negative correlation could also be called the opposite correlation, and like the inverse anyway. Negative correlation is where it goes down. So you can have a positive correlation or a negative correlation. Age and height. How are those correlated? Are they correlated positive or negative? Well, age and height is positive because as you get older, you get taller. But actually, later on in life, sometimes older you get, there's some more, you get shorter. So recognize that some of that can also work. Anyway, positive, negative correlation. Right? Ready? You got it? Well, there's one more thing still to know. Here we go. I can find something to write on. When you have this correlation that occurs, you've got the line of best fit. And let's say the reason we do this is so we can extrapolate out. This graph might go from 0 to 100, but the reason we do that is so we can know what happens at 200 or 300 or 400 or 500 or a million. That's the reason for finding these lines of best fit, is to be able to predict what's going to happen way out on the right or way out on the left. So there's two ways we can predict. You can predict either by graphing, following the graph. Okay, where's the graph going to be at 500? Or you can find by using the formula, by using the prediction model, by using the line of best fits equation. And this is the one we recommend you do. Let's see. I know some of you said blue. I used pink. Anyway, this is the way that we recommend, or that we want you to have the practice today in extrapolating out or making the prediction. What's it going to be at 1,000? Well, don't draw a graph out to 1,000. Just put 1,000. Remember, that's the x-axis. Just put 1,000 into the x and figure out what the y becomes. And that's the work of today, is predicting that out. For example, on the notes page, if you printed that out, clicking on the link and then printing it out, you can see we've got a positive correlation on this problem. And you can see we've got what kind of correlation? Yeah, the negative correlation on this problem. These beautiful math problems. I wish Bob Ross was here to help in some of this wonderful art. We have the data. We have the data's plotted, and we have the line of best fit, and we have the equation. It's basically all given to you. Well, the point is to try to be able to predict out and calculate out. For example, even if the plane ticket was $500. Well, wait, that's the y variable. What do we do there? I'm kind of skipping ahead, but here we go. Describe the correlation of the data. Well, going up. When one goes up, the other goes up. There's the x-axis, the y-axis. So it's a positive correlation. If you traveled 1,000 miles, what would the cost be? Well, let's see, here's 1,000 miles. 1,000 miles, what would the cost? It's somewhere right in there somewhere, between 150, 200, somewhere around 190 or so-ish. But we put that in to the prediction equation, we've got it. y is 0.099 1000s plus 96.665. And when you enter that in the calculator, hopefully you'll get something around 190. Okay, I'm thinking, should I do this? No, I don't. I'm taking too much of your time already. Here we go. 0.099 times 1,000 plus, here we go, 195. Look how good this line of best fit serves us. 195, blah, blah, blah was the answer. You can work that through on all of these. On this one, if the plane ticket costs 500, make sure you put the 500 in the right place. The 500, the cost is the y-axis. So if the plane ticket costs 500, so if y equals 0.099x plus 96.665, then we work that equation to solve for the x. And one way to solve for it is to type it in Google and say, what is x? Or, of course, the minus 96.665 from both sides, 665. So 0.099x is whatever 500 minus that is, 403.335. Then to get the x by itself, just divide that off. So 403.335 minus, no, not minus, Larson, what is it, like the end of the year or something? 0.099, 4,000, what's that? 4,074. Does that make sense? If we're up to 500, there's 300, 304, 500 is somewhere up in here. If that's 500, does this line look like, let's see, we're at, this is 1,000, 2,000, 3, does it seem to you like that's going to be 4,074 when we get there? And yes, it does. So there's that. That was one with the positive correlation. This was one with the negative correlation. You can work out some of those. This is just the notes, though. Just know that you can use the formula right here, this formula, to extrapolate out the numbers you want. And that's the whole beauty of math, is being able to use the equation, whether it's red, green, or blue, or maybe yellow. No yellow. Oh, I got a black. Here we go. Use the equation to make it work. Students, it's been real. It's been great. It's been fun. Hope you've enjoyed this online learning time. It's been nice getting these videos for you. Hopefully it's been beneficial to you, and hopefully you're set. Really do hope that you have a wonderful high school math career. You've shown by your hard work, those are just level 4s, A's and B's. This has been a lot of work, and you've done well on it, and hope you do well. Hope you pass. Just know that if you feel like you've got tons to do, you've still got all next week to get your grade up to where you may want it to be. And don't tell the other teachers I'm telling you this, but if you just do the assessments, your grade will be pretty good. If you just go back and just try those, or just try some of those quizzes, there's those 4 questions, focus on the stuff online, and you'll do great. I'm approaching 10 minutes here. I don't want to hit 10 minutes. So have a wonderful summer. Good to see you. Enjoy. You're the best. Bye-bye.